We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there. Hey there, HackerFrogs. It's me, the Shy Hat, and we're here to do HackerFrogs AfterSchool today. We're here to do HackerFrogs Free Hack, and we're hacking other things. Headless Headhunter has just rated the channel with 11 viewers. Thank you very much, Headless Headhunter. And I hope you were getting up to some fun over on your channel. So what were you up to? Were you doing some cybersecurity stuff? Were you doing some tech stuff? Let us know what you were doing. Anyways, let's talk about what we're going to be doing on today's stream. Reviewed a bunch of resumes, mostly tech. Oh, okay. So is this something you do on a regular basis on your channel? So people are looking for tech jobs. You review the resumes, and you give them advice on how they can improve. Yeah, that sounds like some good stuff. Thank you for letting me know. Okay, so oh, we've got ads running right now. Okay, so I'll wait for about a minute or so for the ads to run by, and then we'll continue on. But anyways, let's just take a little bit of second to talk about what we're going to be doing on today's stream. So today is Friday, May 8th. Okay. Yeah. Oh, 10 resumes. Huh, okay. But yeah, so today is May 8th, and we're going to be covering 4 topics on today's stream. So what we're going to be doing first is we're going to be doing a little bit of a warm-up. I've been working through an AI course, learning some basics about AI and how they operate, and that's what we're going to be doing for the first hour of today's stream. For the second hour, we're going to be doing some forensics, some network security challenges over at the Allah Cyber platform. It's training.allahcyber.it. If you're interested in taking a look at that beforehand, you can find it over here. The site is free to sign up, but it is in Italian. But of course, you can always do your handy-dandy web browser translation tool to be able to access all of the materials over there. And yeah, so what else? So the third thing we're going to be doing today is we're going to be learning about digital forensics ourselves with our program called HackerFrogs AfterSchool. Yeah, we're back. Awesome. Great to hear. Thank you. And yeah, so today what we're going to be doing is we're going to be doing a little bit of learning about digital forensics, specifically something called Steganography. Steganography is a subfield of cybersecurity which deals with the with hiding information within media files. So stuff like picture files or movie files or audio files. And that's going to be the third hour of today's stream. In the fourth hour, we're going to be doing some escape room activities. So escape room basically means that we're trying to escape from our limited privileges on a computer user account. So there's a platform called HackMyVM. Oh, it shouldn't say HackMyVM. It should be PicoCTF. And PicoCTF is a website where you can sign up for, and you can access the machines on their network. We're going to be working on some machines where we need to elevate our privileges, and that's what we're going to be doing with the last hour of today's stream. But without further ado, let's get into the first hour of today's stream, and we'll put 60 minutes on the clock, and we'll get into our course. So the course is free for everybody to do. SysOS says, present, dirty frag was keeping me busy. Dirty frag, I haven't heard of that before. Is that an exercise? Okay, Franz asks, what is your opinion on INE certs? INE, are they what, were they formerly eLearn Security? So INE, eLearn Security, are they the same thing? Okay, Mert Bay says it's a new Linux exploit to escalate like copyfail. Like copyfail? We are going to be covering copyfail next week on Monday. I just didn't have enough time to make room on the schedule today. But yeah, copyfail, we're going to be covering that next week on Monday. Sorry, not Monday, Wednesday. Okay, so let's see. SysOS says, latest LPE in Linux dropped yesterday, like copyfail, only slightly more painful to mitigate. Oh, okay, I think I understand now. Thank you. Okay, John Tar says, wait one more, gotta update my laptop. It's fine, you all can catch up with the lesson a little bit later. Okay, so we've been working through this course called Elements of AI. And I'm pretty sure it's free for everybody to take a look at. But yeah, somebody was talking about the INE certifications. I do have an INE certification back when it was called eLearn Security. It's the EJPT cert. I found that their education was okay, and I also found that it was nice that the examination was hands-on and not a rote memorization test. But that's my opinion on that. Okay, let's see. Franz asks, let's see, INE Certified Incident Responder. I was thinking of doing this. I'm not familiar with that certification, unfortunately, so I really can't offer my opinion on it. But anyways, what were we learning about? So the nearest neighbor classifier. Okay, Tatted One, hello, nice to see you here. Just updated yesterday, yay, update again. Yeah, so we're doing a live stream now, and I guess while we do our live stream, while we're doing our AI topic over here, I can put on a little bit of music. So let me put on the music and then we can get started. Okay, but Tatted One, I saw that you were asking about the Discord in a comment earlier. Here's the link to the Discord over at HackerFrogs. There you go. Okay, music's a bit loud. I'll turn that down a bit. Okay, so we're doing an AI course on machine learning, and we're learning about the nearest neighbor classifier. So the nearest neighbor classifier is among the simplest possible classifiers. We're given an item to classify. It finds the training data item that is most similar to the new item, and it outputs its label. An example is given in the following diagram. So we took a look last time, so that if we got our training set, either green dots or blue dots, and then we have these stars. So the only way this system knows how to classify these stars is to take the item that it's closest to and to assign it with that label. So since this star is closest to a green dot, it labels the star as green. Same thing with this star over here. Okay, in the above diagram we show a collection of training data items, some of which belong to one class green or to another class blue. In addition, there are two test data items, the stars, which we're going to classify using the nearest neighbor method. The two test items are both classified in the green class because their nearest neighbors are both green. See diagram B above. The position of the points in the plot represents in some way the properties of the items. Since we draw the item on a flat two-dimensional surface, you can move in two independent directions. up, down, or left, right. The items have two properties that we can use for comparison. Imagine, for example, representing patients at a clinic in terms of their age and blood sugar level. But the above diagram should be taken just as a visual tool to illustrate the general idea, which is to relate the class values to similarity or proximity nearness. The general idea is by no means restricted to 2 dimensions, and the nearest neighbor classifier can easily be applied to items that are characterized by many more properties than 2. Okay, so defining nearest. Using the geometric distance to decide which is the nearest item may not always be reasonable or even possible. The type of input may vary. For example, be text, where it is not clear how the items are drawn in a geometric representation and how distances should be measured. You should therefore choose the distance metric on a case-by-case basis. Okay, so we're moving down to the exercise over here. So exercise 14, this is customers who bought similar products. In this exercise, we'll build a simple recommendation system for an online shopping application where the user's purchase history is recorded and used to predict which products the user is likely to buy next. We have data from 6 users. For each user, we have recorded their recent shopping history of 4 items, and the item they bought after buying these 4 items. Okay, so what do we have here? We have a user, Sani, who bought boxing gloves, the Moby Dick novel, headphones, sunglasses, and their most recent purchase was coffee beans. And then we've got Joni, who bought a t-shirt, and then coffee beans, a coffee maker, coffee beans, and more coffee beans. So, I mean, we see a pattern start to emerge here that this Joni user is mostly buying coffee-related items. Okay, and then we got sunglasses, sneakers, t-shirts, sneakers, rag wool socks. So it seems like most of the items that are being consumed here are clothing items. Okay, and then we've got this user over here who bought a DVD, headphones, t-shirt, boxing gloves, flip-flops. So there's no real identifiable pattern here. But we've got some beach items, mostly for this user, t-shirt, flip-flops, sunglasses, and sunscreen. But anyways, what are we supposed to do? The most recent purchase is the one in the rightmost column. For example, after buying a t-shirt, flip-flops, and sunglasses in a Moby Dick novel, Villy bought sunscreen. Our hypothesis is that after buying similar items, other users are also likely to buy sunscreen. After buying similar, so if they buy t-shirt, flip-flops, sunglasses, and a novel, so it looks like this person's getting ready for a day at the beach. So if these items are bought, then the next item might or might not be sunscreen. To apply the nearest neighbor method, we need to define what we mean by nearest. This can be done in many different ways, some of which work better than others. Let's use the shopping history to define the similarity, nearness, by counting how many of the items have been purchased by both users. For example, users Villy and Henrik have both bought a t-shirt, so their similarity is 1. Note that flip-flops don't count because we don't include the most recent purchase when calculating the similarity. It is reserved for another purpose. Our task is to predict the next purchase of the customer Travis, who has bought the following products. So Travis has bought. John Tar asks, Villy and Henrik, is this a Swedish website by chance? It's pretty close. This website is Finnish. So I'm pretty sure this was created by people at the University of Helsinki. So it is Nordic, but it's not necessarily Swedish. So okay, user Travis has bought green tea, t-shirt, sunglasses, flip-flops. Okay, you can think of Travis's being our test data, and the above 6 users make our training data. So test data is what we need to test the system as being able to predict, and the training data is the 6 users and their purchase history over here. Okay, you can think of Travis as being the test data and the above 6 users make up our training data. Proceed as follows. 1. Calculate the similarity of Travis relative to the 6 users in the training data, done by adding together the number of similar purchases by the users. Wildroot Radio loves steganography. That's great to hear. We're just going to be doing some basics of steganography today, but I do have some other challenges that involve steganography if you're interested in learning more. Okay, let's talk about this. So calculate the similarity of Travis relative to the other 6 users. I think we can grab this list and then import it into our text editor over here. Okay, so I mean, it's not super pretty, but it will do. And then we've got our Travis user over here. So what we need to do is we need to predict what Travis is going to buy next. Okay, so what we need to do first is we need to figure out the similarity between Travis's history and these other users. So if they bought one of the same item, that counts as 1 on the similarity scale. If they buy 2, then I think it's 2. And I guess the maximum similarity is 4, which is all of the same ones. Billy? Yeah? Let's see. So t-shirt, sunglasses, and flip-flops. T-shirts, flip-flops, sunglasses. So the closest one is Billy, and Billy has a similarity of 3. So 3 items that are... Whoops. So 3 items that are similar between these users. So let's see. Have they made any other purchases that are similar here? So this is similarity 0. Henrik is similarity 2. And Janina, let's see, so that's sunglasses, t-shirt, sunglasses and t-shirt. Okay, so that's similarity 2. And Joni, t-shirt, just t-shirt. So that's a similarity 1. And Sandy's similarity is 1, is also 1. Okay, so we see that the user that is most similar to Travis is Villy. Sunglasses. Wait, where do you see the sunglasses, Edita? Sunglasses here. Okay, so the next step is 1. So 2, having calculated the similarities, identify the user that is most similar to Travis by selecting the largest of the calculated similarities. Selecting the largest of the calculated similarities. So we've identified that Villy is probably the most similar to Travis. And number 3, predict what Travis is likely to purchase next by looking at the most recent purchase of the most similar user in the previous step. Okay, so who is the user most similar to Travis? So we've identified that Villy is the most similar to Travis. And what is the predicted purchase for Travis in this case? So if we look at Villy most recently purchased sunscreen. So Travis most likely is going to purchase sunscreen, or at least that's what we predict. What is the predicted purchase for Travis? Sunscreen. Okay, and we'll submit this answer. And our answers are both correct. When you calculate the similarities between Travis and all the other users, Villy and Travis have the largest similarity with a similarity of 3. Okay, what is the predicted purchase for Travis? Sunscreen. Correct. Since Villy's latest purchase was sunscreen, we will also recommend it to Travis. So you might have seen this if you do any shopping online. So if you use a service like Amazon or any other digital marketplace, you'll see items recommended to you when you go to make your purchase. Okay, so I think we can move on. So in the above example, we only had 6 users' data, and our prediction was probably very unreliable. However, online shopping sites often have millions of users, and the amount of data they produce is massive. In many cases, there are a horde of users whose past behavior is very similar to yours, and whose purchase history gives a pretty good indication of your interests. These predictions can also be self-fulfilling prophecies in the sense that you are more likely to buy a product if it is recommended to you by the system, which makes it tricky to evaluate how well they actually work. The same kind of recommendation systems are also used to recommend music, movies, news, and social media content to users. In the context of news and social media, filters created by such systems can lead to filter bubbles. Okay, filter bubbles. Alright, so as discussed above, recommending news or social media content that a user is likely to click or like may lead to filter bubbles where the users only see content that is in line with their own values and views. 1. Do you think that filter bubbles are harmful? After all, they're created by recommending content that the user likes. What negative consequences, if any, may be associated with filter bubbles? Feel free to look for more information from other sources. Okay, so let's think about this. Okay, so we're talking about filter bubbles. So I mean, we can also think of this as being stuck in one space. So you are only recommended things that you are proven that you respond to. This means that you are only... So I guess one way we could think of this is your YouTube For You page. And let's say that my interests are as follows. So I like gaming, I like computer stuff, tech reviews, and I like... What's a third thing I could really be into? I really like birds. Okay, so let's just say that this is something like me. This should use cookies from other pages too, won't it? Cookies from other pages. Are we talking about are we talking about this course that we're using right now, or something else? Do you wear glasses? I mean, I'm a fairly nerdy person, so the chances of me wearing glasses is pretty high. Anyways, Atval, hello, nice to see you here. Okay, so your YouTube For You page. My interests are gaming, computer stuff, tech reviews, birds. So this means that I will never see videos that are outside these topics. Okay, so this is known as a filter bubble. So is this good? Is this not exactly what I want? Atbow asks, should I be deleting cookies? I don't, because they have all my logins saved. I mean, you might want to try another browser where you're not logged in, and start fresh. And see exactly which websites you want to log into, and that might help you cut down on the number of cookies you have lying around. Okay, John Tar says, like, when are they predicting building our recommendations? Won't they use data from other web pages too? I mean, they might use cookie data from other websites, but aside from using cookies, I'm not too sure how they would use the information from the other websites unless the other websites are actively sharing this information. Imagine 5 years of no cookie deletions. Wow, that's a lot of cookies. So is this good? Is this not exactly what I want? I mean, you will never... Yeah, so you will never see videos that are outside of these topics. This leads to an echo chamber where you only see content that you agree with. I mean, this is more like a political thing. If you're dealing with topics that are not super controversial, so if it's, you know, just like entertainment topics, I don't see how not being exposed to this stuff is such a bad thing. Isn't that, for example, how Meta makes money? Selling data? Conspiracy bubble YouTube. I don't know, maybe. Isn't this how Meta makes money? Selling data? I mean, yeah. Yeah, it's been talked about how certain companies will sell your data to other companies. But I'm not exactly how that directly affects you. It might bear some looking into. Okay, number 2. Think of ways to avoid filter bubbles while still being able to recommend content to suit personal preferences. Think of ways to avoid filter bubbles. Okay, come up with at least one suggestion. You can look for ideas from other sources, but we'd like to hear your own ideas too. Okay, so in news, Monster Drink is up stock-wise. Monster Drink, really? I mean, I'm not really a energy drink. PicoCTF is here, wow. Did you know, everybody, that PicoCTF is a live streamer who does cybersecurity content and is a VTuber? Let's give her a shout out. There you go. If you enjoy more chaotic content and anime avatars and 3D modeling, please check out our channel. Oh, Dirty Frag. Okay, you know what? I think I might need to look into this, because it seems to be a big news thing. Dirty Frag. Okay, let's see. 4 hours ago, Dirty Frag is a newly disclosed Linux local privilege escalation vulnerability affecting kernel networking and memory management. Huh. We got a great Microsoft release over here. I'm gonna have to add this to my list of things to look into. Another privilege escalation Linux vulnerability? Yeah, it seems so. I wonder if this one was... Yeah, I don't know very much about it. So the people in chat, please let us know what you know about Dirty Frag, and whether or not it's something that can be... People say that this is a local privilege escalation vulnerability, right? We've got some time to talk about this because this is our warm-up topic. But PicoCTF went for burgers. Okay, so Dirty Frag. This is a local Linux privilege escalation vulnerability. Spell escalation correctly. Escalation vulnerability. So, does this vuln let any non-root user perform actions as root? So usually this is what local Linux privilege escalation is. So because it's local, that means that you need to already have access local access to the machine. Okay, you can upload 3 specific modules. It does also mess with things like IP security and some crypto. CachyOS does have a fix out for its kernel, so it will come out soon. You can unload. You can't unload on Red Hat. You can't unload on Red Hat. So the Red Hat distribution. Wild Radio Root says Bash Jesus just dropped a Dirty Frag video. Dirty Frag video, haven't watched it yet though. And guess what infrastructure runs on Red Hat? Huh. John Tar says Dirty Frag abuses Linux kernel networking and memory fragment handling behavior involving ESP4, ESP6, and RxR PC components by Microsoft. Okay. So, I mean, this is probably going to get patched in the next couple days. Or it's probably going to get patched by... They're probably going to have a patch out within like 24 hours, right? The important thing is that you update your kernel as soon as you can. Update your Linux ASP AP, everyone. Smiley face. SysOS says it was under embargo, but someone broke the embargo. Fixes were already underway. Oh, are you saying that somebody leaked the information early? But yeah, thank you very much, PicoCTF and SysOS Master, for letting us know about the Dirty Frag. I'll leave the link for the Dirty Frag article here if anybody wants to take a look. It seems that there's like a lot more of this stuff happening on a much more frequent basis these days. It's kind of concerning. Okay, so think of ways to avoid filter bubbles while still being able to recommend content to suit personal preferences. Come up with at least one suggestion. So I mean, we were talking about filter bubbles and how filter bubbles prevent our our recommendation system scenarios where you only get filtered into one kind of content. Canva got attacked. Canva got attacked. But how did they get their initial access to Canva then? Okay, so filter bubble mitigations. How to avoid only... How to avoid getting stuck in a filter bubble. Okay, so I'm pretty sure that YouTube uses this system right here. So have the usual recommendations, but for every X number of recommendations, include one that is different from the usual content the user sees. And I think that YouTube video recommendation uses this kind of implementation. Okay, we'll go back to our course. Note, on using ChatGPT and similar models, we appreciate you putting an AI tool into use. Feel free to consult it, but note that since we are interested in your own opinion, we expect you to write your final answers yourself. Your answers should be at least 20 words. 20 words. Okay, so 1. Do you think filter bubbles are harmful? Okay. 1, do you think filter bubbles are harmful? So I think, depending on what sort of content that is recommended. For example, music versus news versus short-form video or videos. Filter bubbles are not always harmful. The danger. Discord got... Oh yeah, right. I did notice that Discord was down today. So I tried to log into Discord shortly before going on stream, and I noticed I wasn't able to connect. So Discord was attacked by Dirty Frag? Or was it attacked with something else? If you know, let us know in the chat, thank you. Okay, so filter bubbles are not always harmful. The danger from filter bubbles is when users get locked into an echo chamber for news, politics, and other controversial topics. Okay, and number 2. The second part of the question is, think of ways to avoid filter bubbles while still being able to recommend content to suit personal preferences. John Dar says, I thought it was just API errors, or at least that's what it said when trying to load into Discord. API, I mean, it might be a coincidence, or it might not be a coincidence that that Discord is not available, just when this stuff is getting kicked off. Okay, so number 2, API errors are always in for problems. But Panko, how are you doing? How are you doing? I haven't seen you in a few days. I think you did a live stream like a few days ago, right? Hope you're doing okay. I'm good. I'm just busy. It's good to be busy. It's good to be busy. And I hope you're having a good Friday evening. All right. So number 2. One way we can try to alleviate the filter bubble problem is to recommend content that is not what the user usually sees for every X number of recommendations. For example, one different for every 100 regular ones. Okay, so I think this is okay. Dirty Frag and Dirty Copy, Dirty Crag, Dirty Copy, Copy Fail are not so far remotely executable, so you need to weigh in first. Yeah. Okay, so let's submit this answer. Okay, peer reviews given 0 out of 3. It's time to peer review. Below you have a couple of answers from other students. Select one of them and review it. Repeat at least 3 times. Okay, chain it with the Apache one that dropped last week. Easy. Is that one an initial access one? Panko? Too many borked boxes. Okay, so let's see. Filter bubbles can be harmful because people may only see opinions similar to their own. This can limit understanding of different viewpoints and increase misinformation. To avoid filter bubbles, platforms should recommend a mix of different opinions and topics while still showing content related to their interests. I mean, this is pretty straightforward. Okay, answer is on topic. Yeah, it's on topic. Well-reasoned, sure, comprehensive. Yeah, easy to follow. Okay, submit. I'm not very good at doing these peer reviews. So 1, I would think that they are somewhat harmful. There is no doubt that they are narrowing the range of viewpoints, sources, and topics that you encounter. this could definitely end up in polarizing views as there is little to no disagreement. You might be in a tiny minority and never even know it. There is way less healthy discussion of alternative viewpoints. There's also a tendency where it concentrates on things that provoke engagement, and this can be stemming from outrage rather than accuracy. Then it can get into vicious, ever-decreasing circle. What if there were two lists of recommendations, one that goes by the predicted algorithm, and the other that goes outside of your normal predicted preferences, but make it so that the person is made aware of this. Therefore, they're conscious about what is going on, and not being secretly manipulated. What? What if there were two lists of recommendations, one that goes by predicted algorithm, and the other which is outside your normal predicted preferences? So what they're recommending here is that there are two categories of recommendations. So let's say that the recommendations that are similar to what you like is colored blue, and then there are recommendations that are not related to what you like that are colored red. Why would you ever... You would just go by the color that is associated with your recommendations. It seems like kind of a weird answer. But anyways, let's rate this one. Okay, so it is on topic. Yes, it is well reasoned. It's easy to follow, but I don't know. I don't necessarily agree with their answer for number 2 over here, because it doesn't seem like it would work. But I'm not too sure what category we would put this under. Let's just say it is not as well reasoned as we thought it was before. Okay, we'll submit this review, and then we need to do one more. Are filter bubbles harmful? Yes, they trap users in one-sided views, reducing exposure to diverse opinions and increasing social polarization. So I think the people who are answering this question, they're mostly thinking of like super serious topics, because I think that when we're not talking about super serious topics, for example, if we're thinking of stuff like music recommendations or like entertainment related recommendations, it really doesn't matter as much if you're not being recommended stuff that is outside of your normal recommendations or things that you take in. Negative consequences: political division, misinformation spread, reduced critical thinking, and manipulating through outrage-driven content without user awareness. So let's see. SysOS says bubbles are treacherous when not aware, and you do not need to escape them. When not aware, and you don't need to escape them. So let's see. Jontar says, do you think it's not bad if you say all day it's birds or metal music? I think it's good to recommend some pop music or expose people to other hobbies. Maybe not dangerous levels though. SysOS Master says, political bubbles are toxic. I mean, some people, I don't really want to talk too much about politics, but this is something that we have to be aware of, you know, filter bubbles with sensitive topics. Sensitive topics. So the sensitive topics we're talking about are stuff like politics. There's stuff like, I guess it all kind of falls under politics, because politics is where it all kind of divides. And I guess we would like to think that we are nuanced and not not what? That we would like to think we were nuanced and free thinkers, and not influenced by the, what is it called? The norms of our selected political affiliation. Okay, so let's see. John Tar says, I'm just thinking that if you're a Linux user, chances are that you're if you're a Linux user, chances are that you're on a certain political spectrum. And this could be true for a lot of hobbies. So it might seem harmless, but is it fully? I mean, I'm not sure. SysOS says, not knowing your opponent's position and just getting your own pundit's words on the opponent's reinforced is what's bad, without diving into any specific politics. And Hot Plate GRC, kick it. Hello, nice to see you here. What is up? So we like to think that we are nuanced and free thinkers, and that, you know, we're forming our own opinions and not just listening to the leaders of our, or the people who represent our political affiliations and just following what they say. So I guess we would also like to think that we can listen to content that goes against our political affiliation and consume it without bias. But I mean, is this really true though? If you're a left-wing person and you listen to some right-wing like talk show, could you listen to it without thinking that these people are all dumb? And if you're a right-wing person and you listen to a left-wing podcast or a left-wing show about, you know, some political topic, could you listen to it without thinking that these people are all crazy? That's a very important question. Second in Mind says, started early today. Did I start early today? Anyways. Is politics thing part of the box? The politics isn't part of the box. We're just talking about filter bubbles. So filter bubbles are created when systems recommend things to you, and they only recommend things to you that you're interested in. So we're talking about the case where you have some political bias, and you only consume content that aligns with your political bias. Okay, but let's continue. We have a few more minutes left on this startup topic. All right, so, well, I mean, we'd all like to think that we're capable of consuming stuff from the other side without you know, bringing our and being able to identify good points if there are good points that are made. So negative consequences here: political division, misinformation spread, reduced critical thinking and manipulation, outrage-driven content. Suggestions to avoid: algorithms should reserve 20% of recommendations for opposing or novel viewpoints, labeled as outside your bubble for user choice. Yeah, I mean, it's certainly easier if you've got more than two political parties to choose between. It depends on which country you live in. Anyways, so, I mean, if we're talking about just polarized and divisive topics themselves, filter bubbles, of course, are harmful, because you might get captured by your political party's point of view, and that means you're not really doing critical thinking because you're just doing whatever the party leaders are telling you should be thinking. Okay, let's select this one. So Second in Mind says, let's see. I typically gather both sides of a topic from various sources before I ever consider speculating on an opinion for something. I'm definitely a third party kind of person, independent if you will. I mean, it's Yeah, and I mean the thing is that we're also in where was I? We're also in kind of a culture, like cybersecurity practitioners, hackers. These people are usually, well, they actually usually lean towards a certain political bent, but they're also very questioning of authority in most cases. You tend to see a lot of that stuff. Okay, 2 answers correct. Filter bubbles. The era of information and the era of misinformation. we would never. People in the hacker culture? Never. Okay, so I mean I was able to, yeah, so I hate doing peer review. Let's finish this. Okay, so we need to move on to the next section of today's lesson. Regression. Why are we regressing? What is that word? Question? Which word? Questioning authority. We would never question authority. The automod is really catching you, is it? I didn't see it. Allow. Okay. There you go, Second the Mind, you're free. Okay, Wild Radio Root says it's important for most to be most critical of people on my team. I have found sweep my own side of the street and all that. I mean, yeah, I wish it were, you know, I wish people could have more constructive conversations with people who don't share your political views. But it's becoming increasingly more difficult because everybody just kind of retreats to their own side. What are we working on right now? We're working on an AI course. We're talking about... Oh gosh, the AI course got me to talk about politics, although kind of surreptitiously. That's horrible. Okay, so regression. Our main learning objective in this section is another nice example of supervised learning methods, and almost as simple as the nearest neighbor classifier to linear regression. We will introduce its close cousin, logistic regression as well. Google Doci when? Am I going to produce a Google document about the course? Bubbles are nefarious in nature. Shy hat for president. Don't make me president, please. That would be a very, very bad idea. Alright, the difference between classification and regression. Classification and regression. I'm not really too sure what regression means in this case. I understand what classification is. It's, you know, putting something under a specific type. But regression, I'm not really too sure of. Okay, let's see. I prefer straight up honest discussion rather than sneaky backstabbing. I mean, it would be nice to be able... Leader of the free world. It'd be nice to be able to have a question without asking... Here's what happens when we start talking politics in my society, right? So, start a conversation about some political topic. Your conversation partner asks, are you left or right? Immediately after the battle lines are drawn. So it would be nice if it didn't go this way, but anyways. This is the culture thing, I think. Your culture views it as a zero-sum game. Yeah, I mean, it seems like cooperation is in short supply. Sick in the Mind says, regression is more of an analyze and measure, validate, repeat. Analyze, measure, validate, repeat. And then we can categorize after that? Okay, there's a small but important difference in the kind of predictions that we should consider, that we should produce in different scenarios. So, While, for example, the nearest neighbor classifier chooses a class label for any item out of a given set of alternatives, like spam ham or 0 to 9, linear regression produces a numerical prediction that is not constrained to be an integer. So a whole number as opposed to something like 3.14, not constrained. Linear regression produces a numerical prediction that is not an integer. So it's a floating point number. Okay, SysOS Master says, I reject any conversation partner that asks or tells me what political leaning I have before we discuss the actual topic. I mean, I guess the other thing that people would try to do when they're trying to have a political conversation about you is when they try to have a political conversation with you, they'll try to ask you questions about what your views are on other topics. And that can ID you as leaning either left or right. And then from there, they treat you as either left or right, depending on your answers. If you tell them you're a couch potato, they might get mad at you for that as well. Yeah. Okay, so linear regression is better suited in situations where the output variable can be any number, like the price of a product, the distance to an obstacle, the box office revenue of the next Star Wars movie, and so on. The basic idea in linear regression is to add up the effects of each of the feature variables to produce the predicted value. The technical term for the adding up process is linear combination. Okay, SysOS Master says that it presumes that all left or right people have a shared hive mind with only one joint position on all the things. I reject that nonsense. I mean, I'm not saying that everybody who is left has this opinion on something, or that everybody on the right has this opinion on the same topic. But usually some people will try to suss out what side of the political spectrum you lean on by asking questions like, actually, wait, here's what I would ask. So if I wanted to know if a former NSA / CIA / FBI agent toes the company line, toes the company line as far as then I would ask them the question, what is your opinion on Edward Snowden? Did he do the right thing? And if they answer yes or if they answer no, then this might tell me a lot about whether or not they're a person who still is very aligned with the three-letter agency that they used to work for. Okay, let's see. Pinnacle says, just play dumb and let them talk themselves into a hole. John Tar says, it's ironic, we've never had more free information now than before, but we refuse to use it. Anyways, let's continue. Linear regression, linear combination. So the idea is very straightforward and can be illustrated by your shopping bill. Your shopping bill, you say. Okay, thinking of linear regression as a shopping bill. Suppose you go to the grocery store and buy 2.5 kilograms of potatoes, 1.0 kilograms of carrots, and 2 bottles of milk. If the price of the potatoes is 2 euros per kilogram, and the price of carrots is 4 euros per kilogram, and the bottle of milk costs 3 euros, then the bill calculated by the cashier totals 2.5 plus this calculation here. In linear regression, the amount of potatoes, carrots, and milk are inputs in the data. The output is the cost of your shopping, which clearly depends on both the price and how much of each product that you're buying. Okay? The output is the cost of your shopping, but the input are these numbers right here. So the numbers and the cost. The word linear means that the increase in the output when one input feature is increased by some fixed amount is always the same. So linear means the fixed amounts are always the same. In other words, whenever you add, say, 2 kilos of carrots into your shopping basket, the bill goes up by 8 pounds. Sorry, I keep on saying pounds. 8 euros. When you add another 2 kilos, the bill goes up another 8 euros. And if you add half as much, 1 kilogram, the bill goes up exactly half as much, 4 euros. British confirmed? I am not British. It's just that when I see a symbol that is not the dollar sign, I kind of default to pounds for some reason. I'm not as used to seeing the euro sign. Anyways, coefficients or weights. In linear regression terminology, the prices of these different products would be called coefficients or weights. This may appear confusing since we measured the amount of potatoes and carrots by weight, but do not let yourself get tricked by this. Likely story, governor. Yeah. No, not British in the slightest. One of the main advantages of linear regression is easy interpretability. The learned weights may be in fact more interesting than the predictions of the outputs. So for example, when we use linear regression to predict the life expectancy, the weight of smoking cigarettes per day is about minus half a year, meaning that smoking 1 cigarette per day takes you on the average half a year closer to termination. What? Smoking 1 cigarette more per day takes you on average half a year closer to termination. So if you smoke 1 cigarette every day, you lose half a year of life. Likewise, the weight of vegetables consumption, handfuls of vegetables per day, has weight plus 1 year, so eating a handful of greens every day gives you the average 1 more year. Okay, I'm just looking at the topics. These do not make sense to me. Oh! Are you talking about the overlay? Yeah, I'm sorry, the overlay is not correct. I forgot to set it. Okay. Thanks for letting me know, says OS Master, thank you. Okay, so exercise 16, linear regression. I'm pretty sure we're not going to get to this exercise since we only have less than 2 minutes left here. Suppose an extensive study is carried out, and it's found that in a particular country, the life expectancy, the number of years that people live, among non-smoking women that don't eat any vegetables is 80 years. Suppose further that on average, men live 5 years less. Also, take the numbers mentioned above. Every cigarette per day reduces the life expectancy. Every cigarette per day reduces the life expectancy by half a year, and a handful of veggies per day increases it by 1 year. Calculate the life expectancies of the following example cases. Okay, so for example, the first case is a male, subtract 5 years, smokes 8 cigarettes per day, subtract 8 times 0.54 years, and eats 2 handfuls of veggies per day, add 2 times 1 equals 2 years. So the predicted life expectancy is 80 minus 5 minus 4 plus 2 equals 72 years. Okay, so this seems pretty straightforward to me. So you start with a starting figure, and then you adjust the figure depending on the inputs. So cigarettes subtract from the input, or from the total. Cigarettes subtract from the total, and vegetables add to the total. Okay, so your task is to enter the correct value as an integer for the missing sections A, B, and C above. Can we do this super quick? Okay, so we've got the expectancy is 80, so it's 80 years. 80 years by default. So male and male means subtract 5 years, so that's 75. And then 6 handfuls per day of vegetables. Okay, so let's do the calculations real quick. So example 1. Male equals 75 years on average, and then we need to add to this. So in this case, we're going to add 6. We're going to add 6 to the number of years that this person's going to live, because it seems that each handful of vegetables per day adds 1 year. So it's just going to be 75 plus 6, and that's 81. Okay, so what's the second example? So the second example is a female. So females live for 80 years on average, and then we need to subtract the cigarettes. So it's 16 cigarettes per day. So 1 cigarette per day subtracts half a year. So 16 is going to subtract 8 years. So that's 8 years plus 1. So that's going to be 72, 73. Okay, and the last example is going to be a female. So female is 80 years on average, and then we need to add a number of years because of the vegetables. So 4 years because of vegetables. Black Rose, hello, nice to see you here. What is up? We're just finishing up our warm-up topic on the basics of AI stuff. But Black Rose, hello, nice to see you here. Hope you're having a good time. Haven't seen you in a while. Okay, so the answers are 81, 73, and 84. Okay, yep, got those numbers correct. Great. Alright, so we're going to need to skip on over to the next topic. Okay, let's see. Black Rose says, just studying as usual. That looks great. I wasn't around. I was reading a lot of documents and learning Japanese aside. Oh, Black Rose, are you studying Japanese? Where? Well, let me know more about your Japanese study. I used to live in Japan for a couple of years. A lot of things going on. Yep, a lot of things going on. Okay, I was referring to the overlays. Oh, yeah. So we're going to change the overlays now because we're switching topics. So we're doing topic 2, we're doing topic 3 on deck. And so we're going to be doing some challenges from Cyber. So you can make an account over at Cyber yourself. It's a very, very good resource for learning about cybersecurity topics. But the only problem is that it's not in English, it's in Italian. But of course you can auto-translate everything, and then you should be able to get a lot of it out of it anyways. Okay, Cypher says Nihongo tanoshii ne. Okay, all the good streamer things. We're trying to. So what we're gonna do is we're gonna do some of the beginner challenges over here from network security. So network security in this case, they're pretty much exclusively talking about packet captures, and but that's okay. We need to get better at doing our packet captures. Okay, Black Rose says, actually, I'm very new to Japanese. It's always amazed me by the shape of their alphabet and characters, so I said, why not learn this kind of language? I learned hiragana, katakana, and now learning kanji. Awesome, awesome. What kind of learning tools are you using to learn Japanese? Let me know. Panko Panko says, OMG, so kawaii. Yeah, very kawaii indeed. So, yeah, Black Rose, let me know if your native language is close to Japanese at all. I mean, the closest language to Japanese, as far as other languages are concerned, is probably Korean. So, if you know Korean, learning Japanese is much easier, because Japanese and Korean share they share a very similar grammar structure. A lot of words sound somewhat similar. And there's a lot of similar cultural norms. Okay. Let's see. Jontar says, my native language only similarity with Japanese is that we both have pitch accents. Pitch accents, that's interesting. Black Rose says, my native language is Turkish. Oh, okay. I mean, I'm not too sure how similar Turkish is to Japanese, though. But anyways, let's go ahead and put 60 minutes on the clock, and then we will get started with our network security exercises over here. So where we left off was network security challenge number 8. So before we get started, I'm going to go ahead and translate the page from Italian to English. Okay, let's see. Langston's Entropy says, Turkish and Japanese are in the same language family, so they have the same sentence structure. I heard from a friend. That's interesting, Langston, because I've never heard about that. But I mean, I've never done any research on it either, so I'm not really too sure. Okay, so we've got network challenge number 8, bytes mining. So what is this? What are we doing here? So this challenge focuses on analyzing and extracting the bytes of a given package. In this capture, there are brief exchanges of TCP packages, in particular the frames containing the data sent by the IP. The IPs of interest are, let's see, these IP addresses right here, so 192.168.101 and number 2. To get the flag, you need to extract the bytes of this package and analyze its contents. Extract... Okay, I thought Japanese was a language isolate. I mean, I'm pretty sure that Japanese is not directly related to any languages, but the patterns, like the grammatical structure patterns, might occur in a few different languages at a time, but they're not necessarily related to each other. Anyways, let's continue. So in this challenge, and if you want to do this challenge, you need to be logged into Cyber, and we got a PCAP to look at here. So to find the flag, you need to extract the bytes of this package and analyze its contents. So we got our PCAP, we'll download it. And then we can take a look in our Kali Linux over here. Let's just make another tab exclusively for Wireshark. Okay, did we download? I think I just downloaded it, right? Okay, so NW something something PCAP. So we're just, we'll create a directory for this. If anybody's never played this game before, Valhalla, it's got a really nice soundtrack. I highly recommend people look it up if they're interested in this kind of music. Okay, so let's go ahead and move that PCAP to this directory. Okay, and then we'll open it up with Wireshark. Okay, so let's take a look at this. We're only interested in TCP packages, and we're only interested in these two IP addresses. So every time I go into Wireshark, I have to look up how to do filtering, and it's well, it's probably something I need to get used to. Wireshark filter on IP address. So use IP address equals equals. Okay. So we'll go up into the display filter, IP address equals equals 192.168.101, or IP address equals okay, so that gets rid of everything that is not from either of those IP addresses. So IP address equals IP. Yeah. Thank you very much, SysOS Master. So we've got only those packets, and what we need to do is we need to extract bytes from those packets. So where's the challenge again? So to get the flag, you need to extract the packets, extract the bytes of this packet, and analyze the contents. So how do we extract these things? Hot plate, hello, nice to see you. What is that? Follow the stream? Follow the stream. Okay. So we'll go back in. We'll go to the first one. We'll follow TCP stream. Oh. Yeah, so it looks like we need to... Huh. So it looks like there's some non-printable bytes here. So we can save this as something. So we'll save this, these contents as, I don't know, we'll just call it like file contents. We've not really too sure what these things are. Is it for one packet or multiple ones? So when we follow the, there's only one stream here. There's only one TCP stream. Although maybe there is another one over here. Follow TCP stream. It looks like the same thing. Let me check a couple more. Yeah, so they all kind of equate to the same TCP stream over here. And we saved out the file. We'll go back. Okay, so this is what we extracted. So this is data. We got the data, and now what is it? That's a good question. So we can XXD this stuff. The other thing I was thinking of is maybe what we should be doing is we should be trying to extract files from the TCP stream. So go to File, Export Objects. So this would be from HTTP? No. Okay. Usually these challenges are a little bit more straightforward. Analyzing and extracting the bytes of a given package. So in this capture, there's a brief exchange of packages, in particular frame containing these things. For more of an... Okay, they've got a link for us to look at. Maybe we should take a look at the link. So this is our link. Let's take a quick look. So exporting data. Wireshark provides a variety of options for exporting packet data. This section describes general ways to export data from the main Wireshark application. Okay. The Export Specified Packets dialog box. Export specified packets. This is similar to the Save dialog box. See packet range for details on... Export specified packets. So where is this option? So we go back here. Is there an option to export packet contents? So we've got our data over here. Okay, so we got the data in... Okay, Langston's Entropy says, how do you trust these hack challenge websites even in a VM? I don't think there are any secure hypervisors out there on a non-enterprise plan, only except CubesOS, which is more of a VM manager than OS. So, Langston's Entropy, I mean, you're free. You're free to not trust any of these cybersecurity education platforms. We use a lot of them. We use stuff like Hack the Box, Try Hack Me. We're currently using allacyber.it. What we're trying to look for is platforms that look reputable. You can't be 100% sure that the platform that you're using is completely trustworthy, but you have to have enough trust. Of course, everybody can be a little bit more careful when they're doing their OPSEC. I'd say that at the bare minimum would be to work inside of a VM. Okay, so let's see. To get the flag, you need to extract the bytes of this package. Package. Packet data. Export specified packets. Export specified packets. What are the steps to export specified packets in Wireshark? Okay, to export specific packets in Wireshark, use the File Export Specified Packets menu. File Export, okay, let's try that. So here's a larger length packet. We'll go to File, Export Specified Packets. Okay, and then we'll save this as packet dump. We'll just call this packet dump 1. Okay, and then after that's done, this exports it as a PCAP file. So this is still a packet file. What does it look like if I look at the hex dump of this? Alright, this is mostly non-printable bytes. So I wonder what we could... I wonder what they want us to do with this. The frame containing the data is sent by these two IP addresses. To get the flag, you need to extract the bytes of this package and analyze its contents. So, for more information, this. Okay, we got our tags over here, network and in bytes. Okay, steps to export specific packets. Mark the packets. In the packet list pane, click on the packets and click M to mark the individual packets to be saved. And then go to the export menu, export specified packets. Define range. Okay, in the dialog box under packet range, select the packets to export. So I guess what we want to do is we want to export all of these packets. Yeah, I mean, we're definitely missing something. Can I select everything? Okay, so select all of these. So these are the ones that that involve these two IP addresses. So file, export specified packets, and is there a packet range? All packets. So all packets, uncompressed, export as... So we can choose to export it as a PCAP or to export it as something else. But what would we export it as if not a PCAP file? Well, I guess a PCAP file it is then. Okay, so let's see. Langston says, not saying they shouldn't. Do not know this stuff. I just want to learn security measures one should take to participate in these kind of challenges, like hardening. I mean, I'd say that as a student, you should be more concerned about learning the materials. You also should be concerned about practicing proper hygiene. You certainly shouldn't be using the same environment that you do everything else with the same environment where you do security stuff. So my recommendation is to use a VM that is separate from the machine that you use for your daily, computer use. Yeah. Okay, so packet, we'll call this packet extract. Sure. Okay, and then after these packets are extracted, it's interesting that there's not very much information here, but of course it looks different if we run our dump. Even in the dump, there's not very much information here. So I wonder what they want us to do to get the answer for this challenge. Happy New Year, Cypher. Thank you very much. Okay, so we'll go back to the challenge. Analyzing and extracting the bytes of a given package. To get the flag, you need to extract the bytes of the package and analyze its contents. Okay, so we've extracted it, or at least I think we have. We just need to find the right way to examine this file. I guess what we can do is we can do printable. Yeah. Alright, so if we got all of this information here, we could probably just throw this into like CyberChef and then maybe do some transformations on it or something. So this is the raw hex dump of those files. We'll go into CyberChef, our favorite tool, and paste in our input here. And this we're just going to do from hex. Okay, and the delimiter is auto. I mean, there's nothing we can read here. I wonder what other transformations we could do to this. Aside from that, we can also try following the TCP stream again. So show entire conversation. Show as UTF-8 or as something else. So this is what it looks like as the hex dump. Could be base64 encoded. This is base64 encoded. I mean, we could try, yeah. So from base64, maybe we could do a couple of rounds of base64. Base64, the initial input. The initial input? This stuff? I mean, I guess we could try. Okay, let's get rid of this. Doesn't seem to make a lot of sense. So pre-from hex. Silver Viperidae. Hey, nice to see you here. Panko was actually here earlier. Silva. You were pretty regular over on her stream, right? Okay, so let's get rid of these. Yo, yay to the pan, yeah. Yeah, so this one's kind of stumping me. It's a brief exchange of packages. The frame containing the data sent by the IP, these ones. Extract the bytes of the package, analyze its contents. Oh. Maybe I should be extracting the entire thing. The export packet dissections dialog box. So this lets you save the packet list, packet details, and packet bytes as plain TXT, CSS, JSON, or other formats. So we might want to save this as CVS or JSON. Maybe JSON would be better. let's give this a try. Okay, so we'll save all this stuff. Export packet dissections. Export packet dissections as JSON. So we'll save this as, I don't know, extracted.json. And then we'll go back in. Okay, so we've got our... Now, just a second, everybody. Gotta put my music back on. Hey, study bloggers, what is up? Hope you're having a good day. Happy Friday. Huh. The only thing I can think of here is that we should be like grepping out for some sort of flag, because the information here doesn't really scream out at me. But what is this weird IP ID here? Because it looks like some hexadecimal. So IP ID and IP.flags might be another weird looking thing. Okay, if it wants bytes, should you not select export selected bytes? Okay, let's go back in. Export selected packets, export selected dissections. But we don't really have the option to export packet bytes though. Maybe if we just select one. Export packet bytes. The bytes. Okay, Study Blogger says, I was so busy for 2 weeks, so sorry I couldn't attend your streams. No worries, Study Bloggers. People get busy. It's understandable. Okay, very new to this. I don't think it'll be correct. I mean, it's okay. We're just all trying to figure out the answer. So this is, this turns into compressed data. Huh. This saves us as gzip information. So I'm actually interested in some of the stuff we saw in here, because I saw some weird looking hexadecimal stuff. Like IP ID, this is hexadecimal, and then IP flags, this is another hexadecimal. Maybe we should just look for these fields, and they might give us some more insight. So TCP, we got flags. Okay, let's so this thing, and we'll grep on IP ID, for example, and see if we can get something there. Okay, so IP ID, we've got these sets of hexadecimal bytes. So let's do some Linux foo and cut by delimiter. Get field 1? No, get field 2. Okay, so that just gets these. We want to get rid of all the white space first. So we'll tr delete new lines. Okay, so that gets rid of the new lines. And then we want to get rid of the spaces. That gets rid of the spaces. Then I don't even know if this is going to result in anything that we can use. It actually doesn't look like anything we can use here. But I'm not really too sure how else we could solve this challenge, because they're asking us to analyze and extract bytes of a given package. So I'm assuming they're talking about packets, not packages. So we're only looking for TCP packets. So this is, I think this qualifies. Okay, can you show the assignment again? Yeah. So I'll just paste in the instructions into chat. Extract the bytes of the package and analyze its contents. So extracting, I mean, I think we're okay with the extracting, but we're not too sure how we're supposed to analyze them. Yeah, this is the data over here. So we can copy the value. So this should be the data bytes that are being sent back and forth. Oh, you know what? This looks a little bit more. This looks a little bit more usable. This looks like you have a CTF team for competitions. I mean, I'm not super competitive with my CTF stuff. I just do CTF stuff to learn different concepts. But I'm pretty sure if you go over to the HackerFrogs Discord, you could probably come into contact with some people who do CTF stuff on a pretty regular basis. Could you use this in the packet tracer? So let's see, TCP and an IP source and destination Wireshark. Oh, okay. I sat in packet tracer all day. No worries. Okay, so this looks like either decimal to... This is either decimal to ASCII or hex to ASCII. Probably hex to ASCII. Oh, sorry. What is your favorite niche in CC? CC? Cybersecurity? Niche in cybersecurity. I mean, I'm probably most familiar with web stuff. So my answer is web. How do we clear our input? There we go. Clear input. And these numbers here, this is probably from decimal. Not a valid let's see. Delimiter space, delimiter. Looks like there's no delimiter here. Okay, so I guess in this case we need to take our input and we need to do something to this. Huh. So this... Alright, so what would we do to separate these? No, familiar, favorite? What are you checking the most and what do you want to know the most? I mean, these days, I want to learn more about digital forensics. I always want to learn more about binary exploitation, reverse engineering, but I can't always study that stuff. So what we want to do is we want to separate these by pairs. We probably want to use some sort of Python. We could use like a Python script to do this, right? Or we could use bash. Python. Separate or insert space for every 2 characters. Okay, we would use a list comprehension. Oh, okay. This seems easy enough. So we'll go in here. We will create a little Python script. We'll call it parse parse.py. Parse it. Parse it.py. So we have a string, which is equal to this thing. Huh. The string looks a little bit off as well. Okay, so we got our string, and then we've got our little list comprehension. Okay. And then just print the thing out. Never closed. Okay. Join. Is this closed? I think we're good. Alright, so we've got our list of bytes. I'm guessing this is what is it? Decimal to ASCII. So we'll go back into CyberChef and then we'll put all this stuff in. So from decimal, huh? This looks like a this looks like a hot mess. So it's just a bunch of the same character over and over again. Oh, the other thing we could do is we could use another tool called rapid tables. So it's like decimal to ASCII. Although, what if we're not supposed to interpret these as decimal, but we're supposed to interpret these as hex? Okay, so if we interpret this as hex, then it just becomes more hex. From hexadecimal, could be done twice or base 64. Could be. I mean, the stuff that comes out looks like more hex. So from hex, then from hex again. Because this certainly looks like more hexadecimal. And then it just turns into some mess. Okay, so if we've got some hexadecimal bytes, decimal bytes. So let's suppose these are hexadecimal bytes. We paste them in here. ASCII text is equal to this. So the hexadecimal bytes, interesting. So if this is interpreted as hexadecimal bytes, what comes out from the ASCII looks like more hexadecimal bytes. Okay, how do you make CyberChef do magic? Not always guessing encryption. So, I mean, your choice to make CyberChef do magic is intentional, so you'd have to go into the operations, and then you'd have to select magic from here. So you can not have it do magic by selecting other operations instead. So if we do from hex, it turns it into stuff that looks like more hex. Then we do from hex again, then we get some really weird looking stuff. The problem is that this challenge shouldn't be this difficult, because it's in the beginners section of challenges. There's no other information here, though, unfortunately. Try from hex from base 64, because it should be easy. Okay, so from hex from base 64. So we'll just turn this off. We'll grab from base 64. From base 64 turns it into some stuff that's not that great. Huh. What if you press the magic button where the output? What if you press the magic button where the output, it can't do it? Okay, let's suppose we got this stuff here, and then we try some magic. What? Flag. What happened here? From hex space, from hex none, g unzip, flag.txt. What the heck? This is getting too complicated. Okay, well, I mean, I'll take my L, if I need to take my L, because where's the gzip header? That's a good question. Okay, watching you stream from early with a cup of morning, it's really good. Hey, Hanky Lodwig, nice to see you here. Not complicated. Okay, so let's do this ourselves. So it's from hex space and from hex none. From hex space and then from hex none. Okay, we'll get rid of this. We'll do from hex delimiter space. Okay, and we get this, and then we do from hex again. And then we do delimiter none. And I guess what we need to do is we need to interpret this as a binary file. So if this is interpreted as a binary file, then it's a zip file. Okay, let's go back in. So gunzip should be, gunzip should be in the operations. So here, so from hex, and then gunzip, flag.txt, something something. Okay, so I want to... oh, we got our flag. Flag byte extraction is easy. Wow. That's a tar file. And there's the flag. Okay. What I want to do is I want to do my write-up on this to understand what the heck happened. Okay, so we'll go in, we will submit our flag. Yeah, that's the correct flag, okay. And I want to do my write-up. The reason why we do write-ups is because we want to be able to reproduce, and we want to solidify our learning of whatever we learned from our particular exercise. So we'll go back into our walkthroughs for Cyber. And this is going to be for network security introduction. Okay, we're doing... looks like we skipped one. Anyways, this is network 8, I think. Network 8 bytes mining. Good people do a write-up. Yeah, good people do a write-up. Yankee Lodbook says, can you do it in one-line bash command using XSD and Zcat? Probably. We probably could. We should probably figure out how to do that as well. Because, you know, we're clever hacker people. Okay, we're going to add a file, make a new one. We need to get rid of all of our spaces because GitHub does not like spaces. So we'll need the URL of the challenge, the concept of the challenge, and the method of solve. Okay, so where's the challenge? This is the URL here. The concept in this challenge is extracting packet data because that's what we were doing in this challenge. What we need to do was we need to locate a specific packet here, and then in the data section we need to extract the value here. So you can right click, then you can select copy value, and this will copy the exact value that's seen over here. So this thing that looks like hexadecimal bytes. Okay, extracting packet data, also data transformation. That would be something like hexadecimal to ASCII, ASCII to hexadecimal, and hexadecimal to file. Hexadecimal to binary file. Okay, so the method of solve. So go into the Wireshark. Okay, I missed it. The gzip header if 1f8b08. If I remembered it wrong. Yeah, I mean, I guess there would be some magic bytes here, right? We go back into CyberChef. And what we need to do in the output is we need to show hex. So how do we... Because in the output window, usually the output window is only going to be printable characters. But what if we wanted this to not be printable characters? Just save the output. Save the output. Save output to file. Okay, so if we save this to a file, we call it download.dat, sure. Then we go back in. Okay, and then so this is gzip compressed data. So the reason why we know it's gzip compressed data is because we've got our magic bytes here. So 1f8b08. So this is the file header. Like music while you're doing your stuff. No worries, no worries. Hope you are appreciating the live stream. Okay, so if this is a gzip compressed file, then we'd want to gunzip it, gunzip. Actually, we need to rename this first. Or like gz, right? Make it a gz file, and then we can gunzip it. Okay, and that results in download. Okay. So download is a tar archive. So we would tar xvf. Okay, and that results in flag.txt. And flag.txt has our flag. Okay. All right. Well, let's complete the walkthrough. So let's see. Go into Wireshark and isolate the packets from that are both TCP and from either of the two specified IP addresses. And that is this filter right here. Okay, are you allowed to post walkthroughs of any CTFs online, or will people see them as spoilers? It really depends on the CTF platform involved. Some CTF platforms are okay with it, and some CTF platforms are not okay with it. I usually try to do my research as to which CTF platforms are okay with walkthroughs being online, and I don't cover the ones that don't want their walkthroughs to be online. Okay, go into Wireshark and isolate the packets, and then observe there is a packet in the list that has a larger length. Click into the package. Okay, what about try hack me and hack the box? Probably where I'll start. Try hack me doesn't have any restrictions. Hack the box has restrictions as far as their seasonal boxes are concerned. So if the boxes are not retired, they don't want you doing walkthroughs or write-ups on them, or at least not having them public. Yeah, active challenges. So if the challenges are not considered quote-unquote retired, then you're not supposed to do a CTF write-up for it. So click into the packet details pane and scroll to the bottom. In the, what is it called? In the data section at the bottom, right-click and select copy value. Paste the value into a file. Okay, John Tar says, I see, but doing these is probably a great way to build my GitHub repo, isn't it? I mean, if you want to build up a list of skills that you're using to solve these challenges, then yeah, definitely start your write-ups. Okay, Langston's Entropy said, sorry, my phone died while writing. Somebody told me that I need to know my attack surface. I don't think I really have, because nobody cares about me. There is no gain, but I care about privacy. There's no gain. I do care about privacy. I mean, you're right to care about privacy because people don't need to know all of your information unless they absolutely need to. Okay, paste the value into a file. When we look at the value of the file, see that paste the value into a file. So the file that we got was called, I think this was the, like the data.bin file. So data.bin, this looks like, oh, you know what? Did I make this a lot more complicated than I should have? Hold on. Let's go back in. Because this looks like the file itself. This looks like the file itself. This part right here. One F8, whatever. Can we... copy as hex dump. So copy bytes as hex dump, right? So these bytes right here. And then we... echo, no. This hex dump is not what we want. Okay, wait. Can we copy this as hex dump? We'll call this hex dump.bin. Okay, paste this in. Then what we can do with this is we can so this is a hex dump. If we've got a hex dump, we can use XXD to reverse the hex dump. So XXD reverse hex dump dot, well, this is not even a binary file, but reverse it and then output it to reversed.bin. Empty. Why did that come out empty? Okay, just a second, everybody. I'd like to... That's the zip file. Maybe you can export object from that packet. Export object from that packet. Okay, so this is the packet here. Why did I make it way more complicated than it needed to be? Then we select export packet bytes. Export packet bytes. Oh, okay. I did this before. The bytes over here, right? I called it the bytes. I mean, my naming convention is not very good for all this stuff. And it said that the content of the bytes was gzip compressed data. Okay. I'm gonna have to come back to this, and I'm gonna have to do a proper write-up on this. This was actually a lot more simple than what I ended up doing. All right. Anyways, we're gonna do HackerFrogs AfterSchool for the next hour or so, because I've got a number of different topics I got to do. Okay, so topic 2 is done. Topic 3 is here, and topic 4 is on deck. But yeah, this was actually a lot easier than I thought it was. Than I made it out to be. What you actually need to do is you need to just click into here, and then after you've got this packet selected, you go to File, Export Packet Bytes, and then save it as something. And that something is going to be a file, the gzip file that you need to unzip. Anyways, silly me. I'll come back to this challenge and I'll finish my write-up a little bit later. but we've got to do our lesson now. Okay. So let's do HackerFrogs AfterSchool. This is digital forensics. Okay, if anybody wants to know what all the links we're going to be doing are, they're going to be here. Okay, so it looks like we're going to be using some try-hack-me to do this. But before we do that, let's go ahead and get started. So this is session number 2. Alright everybody, this is HackerFrogs AfterSchool, Digital Forensics. Session number 2, this is Steganography. So what is this Steganography thing that everybody's talking about? Hey there HackerFrogs, this is the second intro to Digital Forensics Basics workshop. In the previous workshop we learned about the following digital forensics concepts. We learned about EXIF and image file metadata. Metadata is data that provides information about other data. And in the context of digital image files, each file has a plethora of metadata information which is generated when the picture is taken. Photo metadata, called EXIF, is easily accessible and can reveal information about the device used to take the photo, or even GPS location data about where the photo was taken. We learned about the contents of image files. So we learned about the contents of image files and the difference between text and data. Text is computer content that is meant to be read by humans. And data content is meant to be read by computers and software. It is illegible if not accessed through the proper program or app. So if you were to open up any typical JPEG file in a text editor, you'd find that most of it is garbled and you wouldn't be able to interpret it. So, but if you take the same image file and you put it in an image viewing program, then you can actually see the contents. Okay, and the last thing we learned in the previous session was about embedded files, and how embedded files can be extracted and examined using specialized software. So I think we used a specialized piece of software called binwalk to extract files from image files. Today's topic is going to be covering the following 2 things. We're going to be talking about steganography, and we're going to be talking about a specific tool called the Steghide tool. So steganography, what is this thing? Steganography is the process of hiding information in another medium. For example, hiding a hidden message in a picture. When dealing with digital files, steganography can be used to embed files or messages into different media files, like pictures, videos, and audio files. Okay, we're going to be using the tryhackme.com platform to learn about steganography. And we're going to be learning about the Steghide program as well. So log into tryhackme.com and then navigate to the link below under task number 4. So let me go ahead and get that. So this is the TryHackMe CTF collection volume 1. So just log into TryHackMe and then go to the link. Where are we? No, ChatGPT, not now. Okay, so we're just going to log into TryHackMe first. Okay, and so we're gonna be covering this one on Monday. So the copy fail vulnerability that was all the rage a couple days ago, but apparently new ones have taken its place. But we're gonna be covering copy fail next week on Wednesday. But that's not the room we're looking for. We're looking for CTF collection volume 1. Okay, under CTF collection volume 1, we're going to be accessing Well, I'll show you what it looks like if you have never done this before. So we will leave the room. No, reset progress, and then leave the room. So I just want to show everybody what the room looks like if you're coming on to it for the first time. Okay, so what you want to do first is you want to join the room with the green Join Room button on the right. Click on it. Okay, and then we want to scroll down to task number 4, because that's where the Steganography stuff is. So click on task number 4, and it says something is hiding, that's all you need to know. Something is hiding, that's all you need to know. And there's a download task button over here. It is sad, feed me the flag. It is sad, feed me the flag. So under task number 4, what you want to do is you want to click on download task files. So this is going to get you access to the image we need to do Steganography on. So we need to right click on it and then save image as. So let's see, where are we going to put this? Just a second, everybody. Okay, so everybody, because not everybody necessarily has access to TryHackMe, what I'm going to do is I'm going to share this file on Wormhole, the Wormhole app, just in case you wanted to get a copy of this file. Okay, here it is. Okay, so everybody, if you want to take a look at the same file that we're looking at right now, and you don't want to make an account at TryHackMe, you can use this link. So all you need to do is you need to download this image file, and then we can do some digital forensic stuff on it. Okay, Yapply says, looking into getting a new monitor. Are ultra wides the move? I mean, I don't use ultra wide monitors myself. If anybody here has any opinions on ultra wide monitors, let Yapply know. My answer is no, not ultra wide. You might as well get yourself a couple of like standard monitors. Well, I mean, that's the way I like to do it anyways. Okay, so before we get started, well, we've got our file here. If we do XDG open, on this file, then we can see what the file looks like, but we don't really want to interact with it this way. Okay, so if you don't have access to a machine with a bunch of Steganography tools, this is what I would do. I'd go over to TryHackMe. Where is it? I'd go over to TryHackMe, and then I would start up the attack box, because the attack box has a bunch of CTF tools we can use. So go up to the top of the room, and then click on Start Attack Box. And then your attack box is going to start initializing. So while the attack box is initializing over here, let me go ahead and talk about what Steganography is. Okay, so we're going to be talking about a program we can use to extract hidden files out of image files. It's called Steghide. So Steghide is a program which we can use to embed files into certain types of picture and audio files. If we use the Steghide command with the info function, then we can see if there are any embedded files in the media file. And if we use the Steghide command with the extract function, any embedded files will be extracted and copied to the current directory. Okay, so let's try hiding a file. So after we extract the file, we're going to try creating our own embedded files ourselves. But before that, let's just go and wait for the attack box to finish initializing. So the other thing we're going to check is whether or not we can access the file from the attack box. So this would be task number 4. Okay, so once our attack box is finished initializing, what we really want to do is we want to put the attack box in its own browser tab, because this is a little bit cramped. So what we're going to do is, after the attack box is finished initializing, click into the terminal here, so click into it and then hit enter to close this window. So after that, you want to go to the middle of the screen and then go down to the bottom. There's a button labeled View in Full Screen. You want to click on that, and that's going to initialize your Try Hack Me attack box in full screen, which is much more comfortable to look at. And then we can open up the attack box browser over here. So the browser we can open up with this keyboard shortcut, with this shortcut over here. So for Firefox, so this will start up the web browser inside the virtual machine. Okay, so what we want to do is we want to be very, very quick by going over to Try Hack Me, clicking on Download Task Files, and then grabbing this address, going over to the attack box, pasting in the address in the clipboard, and then paste it into here. Hopefully this will load up, but it could be that we can't really access it this way. If you can't access it this way, I've got a trick that we might want to try. Okay, so it doesn't look like it's going to work. That's fine. So we'll just reload this. Okay, and then we can just close out the browser here, and we'll open up the terminal. So in the terminal, so click on the terminal icon over here, or over here, over here, and what we're going to do is we're going to create our own. We're going to create our own Steganography file. So nano space steg.b64, because we're going to put some b64 encoded information in here. So nano space steg.b64, hit enter. This is going to enter you into the nano text editor. So after that, what I'm going to do is I'm going to give everybody a base64 dump file. Just a second, everybody. Okay, so here's the base64. Didn't get it all. Just a second, everybody. What I'm going to be doing is I'm going to be putting this into a pastebin file that everybody can try to access, if you like. Okay, so that's the whole thing. Copy this, and what I'm going to do is I'm going to create a pastebin out of this. So this is just a little trick you can do for moving moving binary files over from one place to another. Okay, so here's my base64 paste. I'm going to click on Create New Paste. So this is just in case you want to follow along, but you didn't have your own version of Kali Linux or some security version of Linux to work with. Okay, so this is the paste. What you want to do is you want to click into the paste and then select all. So right click, select all. Oh, that doesn't work. That's really ugly. Okay, so just go get the raw. So click on raw, and then select all, then copy it, then go back to your TryHackMe attack box. On the left-hand side, paste this into the clipboard, and then after you've done that, appreciate the extra effort. I understand that not everybody has the access to the same sort of equipment, and I don't want to leave out anybody who doesn't necessarily have their own equipment. Okay, so in the nano here, we've got a file called steg.b64. Click into it, right click, select paste, and then this is going to be the base64 version of the Steganography file. So Control X to save the file, type yes for save, hit enter. And now we've got a file called steg.b64. So to turn this back into a JPEG file, we would use the following command. So it's base64-d space steg.b64, and then output that. So greater than sign steg.jpg, like this. So the command looks like this. Okay, and then you should have a file called steg.jpg now. So if you run file on steg.jpg, it says it's a JPEG image file. If you do xdg open on steg.jpg, you should see the same image from the download link. Okay, now we can start messing around with this using the Steghide program. So to run Steghide, let's make this a little bit bigger, a little bit smaller. To run Steghide, you would type in Steghide info, so Steghide space info space steg.jpg. So this is the file that we want to investigate. So if there's a hidden embedded file in here, Steghide should be able to find it. Okay, and then try to get information about embedded data. Type Y for yes. Enter passphrase. So we don't know the passphrase, but we might be able to get away with just hitting the enter key. Okay, so there was no passphrase in this case. So there's an embedded file in this file called finalmessage.txt. So to extract this, we would run the same command, steghide, but we would use the extract function instead. Steghide space extract, and then steg.jpg. Oh, sorry. When we use the extract, we need to do one more thing. we need to specify -sf for steganography file, and then specify steg.jpg. Okay, hold on. I need to look up what the command is supposed to be. Steghide info, SF, both lowercase letters, okay. This is AES 128. I'm not exactly too sure what the hashing method is. Okay, so this is the command right here. Let me copy this. Okay, so after you've done that, hit enter to give the command. It's going to ask you for the passphrase again. There's no passphrase in this case, so just hit enter. And it said wrote extracted data to finalmessage.txt. So what we did is we took this steg.jpg file and we extracted a file from it that was embedded using steganography. And the final message is over here, finalmessage.txt. So we might as well just read it, and then we've got the flag for this challenge. So THM, sooner or later it is our turn. Okay, so what we want to do to finish the challenge is to grab the flag, go back to the Try Hack Me page, and submit the flag over here. So we're going to be messing around a little bit more with Steghide in just a second. Okay, so just click on the task number 4, paste in the flag here, and then check. Okay, done. Okay. Strogo says, interesting criminals using kinds of steganography and how Freds could track it if somebody transferred these type of files. I mean, originally steganography was used as a method of extracting files, but there's a lot of... Steganography is pretty well known at this point, so it'd be kind of difficult to use common steganography programs to extract data. But let's talk a little bit more about how we can use this program. Where would I put it? So let's try hiding a file. So we'll use our current Try Hack Me attack box terminal to embed a new file into the dinosaur picture with Steghide. And Paki Najumo, thank you very much for subscribing on YouTube. Thank you very much. Okay. So what we would do is we would give a command that looks kind of like this. So when we use Steghide to embed a file into the picture file, we can break down the command like this. So we got Steghide, the command itself, embed, the function to be done. So we can embed a file into another file. So CF is going to be the file to be embedded. The file that we're going to be doing the embedding, rather. So this is the file that we're going to embed into. So we can also set a password at this point, or a passphrase, and this is a passphrase we're going to need to use to access the file in the future. And the file that we're going to embed is going to be a text file, secret.txt. So let me see if I can get the exact command over here. So you can get the exact command in Challenge 2, Steghide embedding tutorial, over on this page. Okay, so we're going to go back to Try Hack Me, and then we're going to create a message. So we're just going to get rid of finalmessage.txt, just remove that thing, and we're going to create a new secret.txt file. Okay, we could give a fun little message like HackerFrogs, like and subscribe, like this, and we can just write this out to secret.txt. Okay, and what we want to do is we want to embed this file into the steg.jpg file here. Okay, I'm very interested in joining the cybersecurity community and useful pointers for beginners. Yeah, for sure, for sure. Check out this website right here, Get Into Cyber. It's got a lot of tips for identifying what role you want to do in cybersecurity and then getting some education resources. Okay, so we're gonna run the command. So since the command is kind of long, I need to refresh myself as well. So where is it? Over here. Okay, so step 8 is the full command we're going to be using to embed into the file. So we're just going to copy that command. We're going to go back to the attack box. Okay, and we're going to need to change some of the file names over here. So it's Steghide embed. So this is the command we're going to give to Steghide. CF is the cover file. The cover file is the file that is going to hold the secret file. And in this case, we called this one steg.jpg. Steg. We need to set a password. We can not set a password, but in most cases, when you're working in Steganography, you want to set a password so that people can't get your stuff unless it's the right person. So we set a password to password123. Langston's entropy says, very interesting, but what if you would hide an unchecked character array executable in C in another file? And how would you run an executable embedded inside an image? That part I don't understand. Well, I'm not really too sure how you would do that either. I'm just teaching people how to embed text files into JPEG files. But it's an interesting thought experiment. Okay, so we set the password as password123, and we need to set an embedded file as well. So this is the file that we're actually going to embed into the JPEG file. In this case, it's secret.txt. Okay, so after we run the command here, it says embedded secret.txt into steg.jpg. Done. Okay? So after we've done that, we can run steghide info one more time on steg.jpg. And it's going to ask, try to get information about embedded data. We can answer yes. And then it asks for the passphrase. Because we've set a passphrase on this particular JPEG file, if we try to select no passphrase, it says assertion failed. That's because we didn't supply the right passphrase. We need to supply the passphrase we set, and the passphrase we set was password123. So we'll do the same thing again. We're going to enter the passphrase password123. And now we see that there's an embedded file called secret.txt in here. And yeah, so somebody was asking about the hashing that was being done. So we got Rindell 128 CBC. So it looks like this is the encryption method. Okay, so to actually extract this again, we can, well, first let's get rid of secret.txt first. Okay, and then we'll run Steghide extract -sf steg.jpg. So this is the same thing we did with the previous file when we were trying to get the flag for the Try Hack Me challenge. It's going to ask for a passphrase. Remember, it's password123. Okay, and it says wrote extracted data to secret.txt. So it's here, and we can read it. Okay, HackerFrogs, like and subscribe. Awesome. Okay, so if there's anything you don't understand about what we were doing during this exercise, let us know. It's just Steganography is something that comes up every once in a while when we do our CTF challenges. It's something we need to make ourselves aware of. And I think there might be one other type of steganography I want to cover before we finish today's lesson. So the program that is used for steganography, it can be a different program depending on what kind of medium is being used. So the most common types of steganography you'll encounter, steganography programs. So if we're dealing with JPEG images, then the program that's usually involved is Steghide or Steghide or Stegseek. So Stegseek is the more powerful version of the Steghide program. The Steghide program is very manual, but the Stegseek program, on the other hand, can be used to brute force the password that is being used for the steganography file. So the other important type of steganography file type is PNG files. PNG images. In this case, you'd use a program called zsteg to extract information from these kind of files. I think I might have a demonstration about this. Hold on. Over at HackMyVM.eu. So HackMyVM.eu, I'm pretty sure they have a number of different steganography challenges. Oh, that's funny. I haven't solved any of these. No, I solved... Total challenge is 14. You solved 14. Did I solve 14? I don't think I did. Anyways, we'll try solving one of these just to show what a typical steganography challenge might look like. So we'll do challenge 19 over here. If you have an account over at HackMyVM.eu, you can do the same challenge that we're doing over here. So flag is inside the file, download. So we'll download this. We've got a zip file. Ah, okay. Okay, looks like you love your Stego. You completed all the Stego challenges. I'm pretty sure I didn't complete all the Stego challenges. Okay, so this is the file we're dealing with over here. Let's see if I can unzip this thing. This is a TXT file. Okay, hold on. I was actually looking for a steganography challenge that had like an image, so that I could show off, like, you know, zsteg or Steghide. Just a second, everybody. Let's try number 22. Actually, you know what? I think what I should be doing is I should be looking at my list of write-ups. Just a second, everybody. Ah, okay. I've got another challenge we can do for Steganography. So this one's from PicoCTF. Your cybersecurity journey at PicoCTF continues at the Scilab Security Academy. Did PicoCTF become Scilab Security Academy? Uh-oh. And it looks like PicoCTF is undergoing a change. Let me see if my old PicoCTF login still works. Just a second. Sorry for the technical difficulties, everybody. Looks like PicoCTF had a huge update. It kind of does. Let's see if my old login still works. Scilab. Has anybody here heard of Scilab before? Oh wow. My PicoCTF login works here. That's good, but I'm kind of surprised that PicoCTF has changed. I'm gonna have to look into this later. But everybody, if you have an account over at PicoCTF, you can log in with your PicoCTF account over at learn.scilabacademy.org. This is very surprising. Okay, so where are my challenges? I'm looking for one called Hidden in Plain Sight. This one right here. Wow. I kind of don't like the color scheme of the website. Anyways, if you're logged into the website, you should be able to see it over here. Alright, you're giving a seemingly ordinary JPEG image. Something is tucked away out of sight inside the file. Your task is to discover the hidden payload and extract the flag. You can download the JPEG image over here. Let's see if everybody can access this. Okay, everybody let me know if you can look at this. If you can look at this without being logged into the website here. Let's see, let's put this in a new private window. Okay, so it seems like you don't need to be logged in to download this file. Okay, cool. Okay, so we'll just move this into our current directory. I'll get rid of some of this other fluff first. What was that file called? Like img? Works without login. Yes, thank you. Thank you for letting me know about that. Okay, so we got image.jpg, right? So we can xdg open. Image.jpg, and it just looks like this. What is the challenge called? The challenge is called Hidden in Plain Sight. Let me get that for you. So it is over here, and it looks like PicoCTF has moved over to this platform called Scilab. Anyways, so okay. So we got this image here, and we need to extract some information from this. So since we know that this is Steganography, because I looked it up because of steganography. What I want you to do is I want you to try using the steganography techniques that we talked about during this lesson to extract the flag. So remember, when you run the Steghide program, it's Steghide info file name, or it's Steghide extract SF file name. So this just gets info about the hidden files. And this other command, this actually extracts the hidden file. Okay, and study bloggers thinks, do you think cybersecurity will be endangered due to AI stuff and all? There's going to be less people. There's going to be less people being hired because of AI. I'm pretty sure that's not in question. But how many less people are going to be in cybersecurity, I'm not exactly sure. Okay, so if we go back, and then we run, actually, potentially less individuals because AI will be seen as a volume intensifier. What is it called? Like force multiplier, right? So we can run Steghide info on image.jpg. Okay, so try to get information about embedded data. Y for yes. Enter passphrase. We don't know a passphrase. Just hit enter. Could not extract any data with that passphrase. Okay, so we don't know the passphrase, so we need to get the passphrase somehow. So remember that yeah, every cybersecurity channel has a lot of people asking about AI and whether or not it's going to destroy cybersecurity, all that good stuff. So the other thing we can do is we can try to get information about the image file. Remember from last time, from the last session, we used the EXIF tool to get information about the metadata on this file. Okay, and we see this. What kind of information do you think this might be? Riyadh Gamer, hello, nice to see you here. Will affect entry-level positions. There's going to be a lot less entry-level positions because companies are going to expect AI to be able to reduce the number of entry-level positions that the hiring managers can hire for. And I think it's going to be a big mistake. It's going to reduce sick in the mind. Yes, you think it's going to reduce the senior footprint. So some people think that it's going to reduce the number of seniors that are being hired, and some people think that it's going to reduce the number of juniors that are being hired. So which direction that's going to go in, I'm not exactly sure. Less seniors, more juniors. Less seniors, more juniors with AI help. Maybe, but anyways, this information right here, it could be a few different types of embedded encoded information. So we could try base64. So this is a comment. Comment, echo out this thing, and then base64 decode it. And then we get Steghide. So we get the word Steghide, and then we get more base64 encoded strings. So if we take this, and then we base64 decode it again, then we get this password, this password over here. So what we're going to do is we're going to copy this, and when we run our Steghide program again, and it asks us for the password, we're going to paste in that password. So just paste, hit enter, and then it says that there is a flag.txt file embedded in here. Sick the Mind says companies will see this as a good thing with budget cuts. I mean, cutting out seniors, it will seem attractive to the companies because seniors usually demand like a higher salary, of course. Okay, I think there will be a new job market for AI safety and it'll be big. The harness can't always keep the edit in the dir root. I painfully learned to only use ask before edit mode that's necessary. Okay, AI must forget so you can normally study networking than Linux and want to become a bug bounty hunter. Okay, so we know that there's a flag.txt file in here. The only thing we need to do now is we need to extract it. Remember that the password is over here. So we'll run Steghide extract instead of info. So we'll just go here, we'll replace info with extract, and then -sf for the steganography file we want to extract from. Hit enter, it's going to ask for the passphrase. So the passphrase, we'll paste it in again. Hit enter, and then we've got our flag.txt file here. Okay, so cat flag.txt, and we've got our flag value. So PicoCTF hidden in the image. So we just copy this, and then we'll submit this to the challenge. Submit flag, and then it says correct flag. So, I mean, I feel like the interface for the website here is a bit less friendly than PicoCTF. Although I guess we're in dark mode. If we switch it over to light mode, then everybody complains about it being in light mode. So I'll switch it back to dark mode. Okay, so the other thing we've got is I think we've got a web shell here too. Yeah, we've got the same old web shell that we were dealing with. So PicoCTF really became Scilab. Riyadh Gamer asks, is the roadmap good? The roadmap? Are you talking about the roadmap in the website here, Get Into Cyber? This one? Or are you talking about another roadmap? Okay, we can pop this out. Webshell.scilab Academy, yeah. Alright, we can make this nice and big. Ah, okay, so it's still the same PicoCTF web shell. It's funny that, well, I mean, the flag contents are all the same because they probably thought it would be a big, mess to go in there and change all the flag formats. Let's see. Yeah, SysOS says, can you sound less like an LLM? If we switch it to light mode, then everybody will complain, so I'll switch it to dark mode. Is that what the LLM say? But, hey, Dante Estrada, thank you very much for subscribing on YouTube. Thank you. But I want to take a couple of minutes just to take a look at what's happening over at. You know what? We'll wrap up. We'll wrap up our lesson, and then we'll take a look at what's happened to PicoCTF, because it seems like a really big change over here. Okay, so let's end our lesson. Okay, let's review the digital forensics concepts we learned in this workshop. Okay. Steganography. Steganography is the process of hiding information in another medium, for example, hiding a hidden message in a picture. When dealing with digital files, steganography can be used to embed files or messages into different media files like pictures, videos, or audio files. Steghide is a program which can be used to embed files into certain types of picture and audio files. And embedding files with Steghide can also use password protection for added security. What's next? In the next digital forensics workshop, we'll introduce network traffic analysis with the TryHackMe platform. I wonder if, yeah, okay. So we're going to be doing some network traffic analysis. And let me just see what we're going to be dealing with. Just a second. Okay, this is going to be session number 3. I just need to... okay, so network traffic analysis. We're going to be talking about network logs, we're going to be talking about packet capture files, and we're going to be talking about Wireshark. So if you're interested in learning about all that stuff, it's going to be on Wednesday of next week. So we've got our schedule for next week over here. Just a second. Okay, so this is the schedule for next week if you want to take a look at it. And otherwise, we're going to spend about 8 minutes taking a look at the new PicoCTF website, because I'm very curious about what they've changed and what new stuff they have. Okay, so let's go over to Scilab Security Academy. Huh. Okay, so open workspace. Open workspace. Select a challenge from the list to get started. So we can do all categories, all difficulty levels, all events. So are all of these PicoCTF? Challenge library exclusive, PicoCTF. These are all PicoCTF. So there are no other platforms that have been... This is exclusively PicoCTF. All right. So let's see. We got Learn, Classroom, Events. We have our resources, CTF primers, external resources, community. Huh. So what if we wanted to get started? Start here. Cybersecurity learned by doing. No experience needed. Learn at your own pace. With your class or in a live event, always free. So I mean, it's good that they're not becoming like a paid platform, because that would be kind of concerning. How the platform fits together. So challenges, learning paths, events, and classrooms. Your first 3 steps. Pick your direction. Start with the learning path. Solve challenges. Each challenge is hints. And level up. Join an event when you're ready to compete. Okay. One interesting thing about the most current PicoCTF challenges that they had blockchain challenges involving cryptocurrency and like smart contracts. I'm kind of interested to take a look at that stuff. Okay, it's common beginner questions. Is it free? Every challenge, every learning path, every event on the platform is free. Do I need programming experience? No. What's a flag? Okay. Anyways, well, we're probably going to be coming back to this a lot later, but let's start into the last part of today's challenge. So the last part of today's challenge is going to be EchoCTF, and what we're going to do is we're going to be doing some escape room challenges. So by escape room, what we mean is we're trying to get further privileges than what we actually have. Let me explain. Okay. Is the roadmap good? So, Riyadh Gamer, I asked you before, which roadmap are you referring to? So if you're talking about a roadmap on a specific website, let me know which website you're talking about. Otherwise, I'm not sure. Okay, so Riyadh Gamer also says, I've learned Python and I'm going to be studying networking then Linux. and then I want to be a bug bounty hunter. Oh, okay, that roadmap. I've learned Python, I'm going to study networking, then Linux, and then I want to become a bug bounty hunter. So, you want your first job in cybersecurity to be bug bounty hunting? I wouldn't recommend your first job in cybersecurity to be bug bounty hunting. If you want to go in that direction eventually, I'd say that your best bet is to learn about how to be a web app security tester first, and then after working as a web app security tester for an amount of time, then you can branch out into bug bounty hunting. Bug bounty hunting as a first job in cybersecurity with no technical background before that is a very, very bad idea. But take a look at the education resources over here. Okay, so this is the escape rooms network over at echoctf.red. So echoctf is another cybersecurity education platform, and this network over here has 10 targets. What we need to do is we need to connect to their network to access their machines. I'll teach you how to do it. App security first. Yeah, web app security first before going into bug bounty hunting. If you try to go into bug bounty hunting immediately, you will have a very bad time. Okay. So echoctf.red is a platform you can make a free account for it. After you've created your account, you can go over to your profile. Hold on. Yeah, okay. So this is what you need to do. You need to make sure that your interface is small enough to get your sidebar. And then click on your profile. And then under the profile actions over here, you can download your VPN key. So download echoctf version 2.5, version 2.6. That'll download the VPN key that you need to use to access the network. Okay, I'll do some CTFs. Yeah, I mean, if you wanted to start off by learning CTF stuff, the other big resource I'd recommend to you if you want to eventually get into bug bounty hunting is Portswigger Academy. So Portswigger Academy is a very, very good learning resource for learning about web app security stuff. And it's all completely free. Okay, so what we need to do first is we need to access the echoctf network. So after we've downloaded our key, okay, E8H Truther, hello, doing a CTF this weekend if you want to make a team and collab. I mean, if anybody wants to collab with E8H Truther, let us know in the chat in Twitch. Thank you. Okay, so the last activity here, we've got about 50 minutes that we can spend on doing this activity. Okay, just a second. Okay, we've got our VPN keys over here. This is where I keep all my VPN keys for our various platforms. We've got a lot of these keys. So the one I'm going to be using is for echoctf. So I'm just going to grab this file name. We're going to sudo openvpn to access the challenge environment here. Okay, so what we need to do is we need to make sure that we have a proper connection. The way we do that is we use our IP command and we make sure that we've got a ton0 interface or a ton interface. So the ton interface is the one that's usually used for VPN connections. And in this case, we've got our IP address. If you got an IP address, it's a pretty good indication that you're connected to the network. From here, we're gonna go into one of these challenges. So which one of these challenges are we gonna do? Sorry. The network we're going to be using is the Escape Rooms network. Let's go to that network. Tunneled interfaces like VPNs or PPPTP connections. That's a lot of P's. Okay, so I think we're going to try the Pathfinder challenge over here. So we're just going to click into it. And if you want to do the same box that we're doing over here, here's the link. It might even be 1 P too many. Can you have too many P's? So this is an advanced challenge, non-rootable timed. Great. So how's your OS escalation skills? How about your binary exploitation? Uh-oh. Binary exploitation. See if you can reach the final user, ETSCTF. On each user you can successfully escalate. There will be a flag on its home directory. The flag can be used as a password to directly switch to that user. Okay? Alright, so this is good. So to start the challenge, connect with Telnet, Netcat or Telnet. Okay, CCNA 200 or 301 is good for network. Yeah, I'm a very British person, of course. Riyadh Gamer, I mean, I'd recommend starting with just the Network Plus. Like it says on the website over here, there's a few resources for learning about Network Plus. Network Plus is maybe a little bit easier because it doesn't have like Cisco specific technologies in the course. Of course, you don't need to get the certifications, you just need to know the information that's covered in the course. Okay, so let's go ahead and get started. How's your OS escalation and binary exploitation skills look like? That's a good question. So we will power up the target, and then we will start hacking against it. And I guess due to the way we're doing this, we'll try to do a little write-up as we're working through this challenge. So let's set that up. So this is a walkthrough for PicoCTF, and this is the Escape Rooms network. And this challenge is called Pathfinder. Okay, so we got our URL, we've got our concepts, and our method of solving the challenge. Alright, so let's see what our IP address is. Okay, so 10.0.40.14. We're just going to see if we can ping this machine first. So if we've got responses back from the IP address, that means we're connected to their network, and we can begin the challenge. So to begin the challenge, we're just going to give a nmap command. So this is a pretty typical nmap command we're going to use to try to discover open ports on the target. But then again, we were actually told exactly what we needed to do to access the target. So the command we were given over here. So netcat on the lead port, on the lead port 1337. So we can go ahead and do that. So in our remote access panel, we will run this command. So what we're doing essentially right here is we're establishing a bind shell, which is kind of rare in these CTF challenges, but fun to use nonetheless. Code Langston says, what are the challenges reachable by OpenVPN? Is it so people don't have to expose their real IPs? It's so that the platform doesn't have to expose their infrastructure to the internet. So the reason why these platforms choose to keep everything in their private network is so that they don't have random people trying to attack their systems from the internet. The people that are attacking their systems have to at least sign up for their service and use a VPN key to access their network. It's pretty much the same with every other major platform. So TryHackMe does the same thing. HackTheBox does the same thing. If there's actual infrastructure that you need to access, they're going to put it. They're going to make it private. Yeah, and because these are intentionally vulnerable machines, you don't want to put them out on the public internet. That's not a good idea. Okay, so we were now opportunity at Pathfinder. So the first thing we want to do is we probably want to get ourselves a... I think we've got a bash shell already. Yeah, so this is a bash shell. And we want to do, typically on these kind of escape room challenges, is you want to see if this user has particular sudo permissions. So let's see, we can run the following commands on Pathfinder. No password bin ls. So bin ls means that we can read the contents of folders as the curiosity user, not as any other user, just the curiosity user. Okay, so what can we do with this information? Let's start the write-up. So the URL, let me go ahead and record that real quick. No worries, I'm here to answer as many questions as I can. Okay, so this is all about privilege escalation using misconfigured sudo commands, and probably privilege escalation using misconfigured insecure binaries. Although misconfigured sudo commands and insecure binaries are kind of the same thing, I guess we can call these insecure custom binaries. Okay, so the method to solve in this case is our first user is named, what was it, opportunity? Opportunity. Okay. This user has sudo access with the ls command in the context of the curiosity user. Okay, so here's the thing. If we've got elevated privileges with the ls command as this curiosity user, the first thing that comes to mind is reading the curiosity user's directory, because that's a directory that typically only they would be able to see. So it'd be sudo u curiosity bin ls home curiosity. Like this. Okay, so this is, I think this is their password. I could be wrong, but I'm pretty sure this is the password for the next level, because they talked about it in the challenge description here. So on each user that you successfully escalate, there'll be a flag on its home directory. This flag can also be used as a password to directly switch to that user. So SU opportunity at a later time, so you don't need to go through the steps every time you connect. So this is the first privilege escalation. So let me submit this flag first. Okay, so that was the correct flag, and the next thing we need to do is we need to become the curiosity user. So let me just get out of here. So this is the curiosity user. So I'm just gonna record the password here, and then we'll log in as the curiosity user. So we're just gonna use SSH instead of netcat because it's a bit more convenient. Connection refused. Huh. Is there only one port open on this thing? Yeah, so there's only one port open on this thing. Alright. So there's a password so that they can switch over. So switching over doesn't necessarily mean they've got an SSH port. Alright, that's fine. Okay, so switch user curiosity. Okay, so we're now the curiosity user, so we can continue on. So before we do that, let's include this in our write-up. So this is the opportunity user. So the next section is the curiosity user. Okay, so we've got sudo access with the ls command in the context of the curiosity user. We can use this command to access the password for the curiosity user, because it's just sitting in their home directory. Okay, the command was sudo u curiosity Am I spelling the word curiosity incorrectly all this time? How do you spell it? No, I'm not. Okay, that's great. So sudo u curiosity bin ls / home curiosity. Okay, so as the curiosity user, let's take a look at what's in this directory. So in this directory, we've got our password here, but there's also, well, let's figure out what sudo permissions we have. Okay, user curiosity may run the following commands on Pathfinder. As the insight user, set env, no password, user local bin insight. Okay, so now we've started encountering some custom binaries. So what we need to do is we need to investigate what this thing is. Okay, so before we do this, we know the next user is the insight user, so let's go ahead and record that. And we'll also record that this user has sudo permissions with the insight user. With the user local sbin insight binary. Okay, so the next thing we need to do is we need to figure out what this thing is. So it can run maybe... Oh, there's no file command. Okay, fine. Okay, so this is owned by root, but with the insight group. User local sbin insight. All right, we've got ads coming up in just a second. When the ads come up, we will take a little break, and that gives me a good opportunity to have a little bit of water. Actually, let me start it right now, because I need to have some water now. But in the meantime, check out these birds. Wow, these guys are getting along. Okay, we'll be back in about 30 seconds. I just need to have a little bit of water. But enjoy the music and enjoy the birds. Just gonna wait another 45 seconds or so. I'll say that these are pretty noisy birds. Anyways, let's put the birds away and let's get back to the hacking. Just a second, I just want to see... Do these guys start? Ah, okay. Alright. Oh. That's... Anyways, let's get back to the hacking. Okay, so what is this user local sbin insight file over here? So we can do some investigation on this. We can read the file. We can read this. We can execute this if we're executing it in the context of the insight user. So just for fun, we'll try running it. Sudo u insight. Okay, so it says nothing to see here, just a plain old printf. Printf. So I mean, if this binary is using printf, it might be vulnerable to... Printf, huh? Okay, so we can read the file, and because we can read the file, we can probably move it off of this off the server so that we can do a little bit of analysis. So we're just gonna cat this thing and then turn it into base64 information. So like we did earlier on today, we're going to take the base64 encoded information and we're going to turn it back into a binary file on the other end. So we just need to copy all this stuff. And then we're going to go back to our terminal. We'll call it insight.b64. And then we'll modify this information and turn it back into its original form, like this. Base64 insight.b64 redirect into insight. Okay, that looks like a vulnerability for setenv. Jackson America, hello, nice to see you here. What is up? Hope you're having a good day. Yeah, it might be a vulnerability for setenv. Working really hard, appreciate your work. Thank you very much. Trying to, let's run some strings on Insight. What? Oh, okay. I ran my command incorrectly. I ran base64 instead of base64 decode. Alright. That was my bad. Okay. So what do we have here? So it's set UID, puts set EUID, set GID. Let's see. Nothing to see. Nothing to see here. Move along. Just a plain old printf. Yeah, thank you very much for letting me know, Henki. That was a big old typo on my part. Have you heard about the hantavirus? I have heard about the hantavirus. Thank you for the typo. So it's the shy 31 typo. If you're on Twitch and you see me making some typos, please don't hesitate to put some of these in chat. Okay, Jackson says, I want to become a hacker. How can I start my journey? What programming languages do I need to learn? I mean, I would suggest if you want to learn a first programming language, I would go with Python. So if you go over to our education resources over here and then go to programming. Awesome stream as always. Gotta go. Love and peace. Thank you very much, Langston, and hope to see you next time. So go over to the education resources, click on programming languages, and then look at the Python education resources. There are a couple of good courses there. I'd say that the ones from oh gosh, what are they called? Open Learning. Those are some good ones over there, and they're free, so the price is right. Okay, so plain old printf. So what does it print? So the other thing we could do for this is we could start reverse engineering the insight binary here. Just for fun, I'm going to take a look. Okay, please show me your Linux PC, Kali Linux, if possible. Print out something. Print out something. If it uses printf, it must be a format string. A format string vulnerability? Maybe. But Jackson America, if you want to a little guide on how to set up your own Kali Linux VM, I've got a video on my channel that you can take a look at. So this one right here. I hate printers. I mean, this isn't necessarily a printer we're dealing with, we're just dealing with a binary that prints out stuff. Okay, so we made this executable, now we can use our favorite program, Radare2, to see what it's actually doing. Okay, so what is it doing? It's not actually doing very much. So it runs set UID. Set UID. It sets set GID. So it sets us to the UID and the GID of the insight user, and then nothing to see here, just move along, just a plain old printf. Just a plain old printf. Printf usually is a vulnerability on the format string. So it runs set UID, set GID, set E UID. But it actually, I don't see it actually running printf. So maybe it's not a format string vulnerability at all. It loads the string in, and then it prints it using puts. Jump, symbol, puts. Okay. Jackson says, with the help of Linux, I think you can develop your own version of the operating system. You can definitely make your own distribution of Linux if you modify it a bit. Puts reads from standard input. Standard input? Huh. So do we have to give additional arguments here? Alright. Sudo user local bin insight. Okay, just a second. Sudo u insight. Okay, nothing to see here. Move along. Just a plain old printf. Plain old printf. So, I mean, we tried giving an argument to the command. It really didn't make too much of a difference. So I'll run all functions list and pipe it out to less. So there is a puts function, a set GID function, set UID function, set EUID function, a main function, but not very much else. Please find out how to use the set env on the sudo command. Set env. I mean, we've got CNV, set env here. So set env with no password. So can we set the env to? It's been a while since I've done this kind of privilege escalation. Let me think about this. Let's try going over to GTFO bins. Nothing for printf, huh? Okay, so we're doing Linux set env binary privilege escalation. Okay. Privilege escalation, Linux via set env environment variable manipulation typically involves abusing SUID, set user ID binaries, or misconfigured pseudo permissions that trust the user's applied environment variables. Okay, so I mean, is it LD preload? So if an SUID binary relies on relative paths or fails to sanitize environment variables, like path, LD preload, or app-defined variables, an attacker can redirect its behavior. Okay, pivot from low privilege user to root or another high privilege user. So let me take a look at what's going on here. Right, so we're inspecting. Let's get out of here first. I want to try running first strace, and then ltrace. Okay, we've got some libraries. Then we'll try ltrace. So the set UID, set GID, set EUID, and then the puts. So we saw that there were some like library calls up here. So they're accessing etc LDSO preload. No such file or directory. I mean, it doesn't exist in my environment, but I wonder if this file exists on the server. And also looking for etc LDSO.cache. Okay, so this doesn't exist. So this file doesn't exist on either, well, etc LDSO preload. I mean, the thing is that we probably, if it's looking for it in the etc directory, then we probably can't write to this. Yeah, so if we go back up here, this directory is not writable. So there was another one, right? This one's also in the etc directory. Etc LDSO cache, etc LDSO preload. Try copying the bin bash as that file. Bin bash as that file. Huh. Could that work? Well, I'll give it a try. I'll give it a try. Okay, so we could probably but can we copy it? Because it's a root-owned file. We'll give it a try. So it's like copy bin bash to this. Yeah, so we can't make a copy of bin bash because, well, we can't make a copy of bin bash because it's permission denied on the etc directory. So the other thing we could do is we could take a look at the other files. So this was preload. There were a couple of other ones as well. What about... ldso.cache. Okay, so this file exists and it's readable. It exists and it's readable. So I don't see any... Yeah, we can't really modify this file. Okay, was there a third file? So it's preload, we got so cache, and this one over here. So libc.so.6. This is more likely to be writable, this directory. Let's check it out. So this is a no such file or directory. Okay, that's fine. Let's check out the directory that it's under. This is another root owned directory. So there's very slim chance that we'd be able to write anything here. Yeah. We can't do anything to the stuff in here. Okay, so what's the next step? So we found 3 files that are being referenced here. Nothing to see here, move along, just a plain old printf. Just a plain old printf. So it doesn't seem to be trying to access any other files. Okay, I need to switch over my playlist one more time. This is a fun little soundtrack. Okay. So insight. So the insight user, we can't look in their home directory. So it says set env with no password with the insight user. So set env means it uses our environment variables, so whatever we set as the environment variables. Just a second, let me... Supervisor process name opportunity. Let's see, path. We've got a flag. Well, I might as well copy and submit this flag right now, since, since we're here. Okay, we got our flag. Okay, so I think we should be able to modify one of these environment variables to help us out. Old password home opportunity supervisor enabled 1. Non-interactive. It's so easy. Can you give me a hand? So let's see. Present working directory, home curiosity, log name, home. So which one of these variables do we need to manipulate? Nerdy Science has just subscribed with Twitch Prime. Thank you very much, Nerdy Science. And if you're interested in doing what Nerdy Science has done and circumvented the system to give me a little bit of money, then you can follow this link. Nerdy Science, thank you very much. Let's give you a fun video redeem. How about some Hack the Planet for you, my friend? Okay. Huh, why is the redeem not coming through? The bot seems to be a bit slow today. Just a second, everybody. Okay, Hanky Ludwig says, use that flag as a password, maybe to get insight like curiosity. Use that flag to get insight? I mean, I don't think this is how it works. Let me take a look. The flag isn't like a username flag, I don't think. But yeah, Nerdy Science, thank you for the Twitch Prime sub. Thank you. Why is the system not doing through? Okay, so how many flags do we have? So there's 5 flags, 4 application, 1 environment. 4 application, 1 environment. So I think we've already gotten the environment flag. Yeah, got the opportunity environment flag of Pathfinder for 100 points. So it's getting started with Pathfinder. Oh, let me reload this page. Yeah, so the curiosity flag and then the opportunity environment flag. The Beldam, hello, nice to see you here. What is up? Okay, so Langston, as before I go, genuine question. I cannot install VBox or VMware because I'm using a school PC. So I set the Linux desktop VMs from WSL by running QEMU CLI. Is it dumb to run QEMU on top of a Hyper-V? I mean, that's probably a question that SysOS Master could answer, but I don't have an answer for you right now about that. Monster Boy, hello, nice to see you here, and thank you very much. And thank you very much for the follow on Twitch. Thank you very much. And Kamakut, hello. We're just trying to figure out this privilege escalation. So we got So plain old printf, that's the only thing it does. We got a few different libraries, but we can't modify the libraries. And thank you very much for the follow, the Beldam. Thank you. I think we asked a little question about this. Okay, so an SUID binary executes system PS. Create a malicious executable named PS that spawns a shell. SUID binary executes system PS. I mean, this is modify the path. Oh, wait. No, okay. That we're doing path hijacking. We're doing path hijacking. Yeah. So we can set the path, and then we can set the library that it's trying to reference. So it's trying to reference this library right here that doesn't exist. The problem is that this is an absolute file path. We need to find like a relative file path for this to work. Or do we need to have a relative file path? Yeah, not sure. Because we've got references to etc ld preload, etc ld so cache. We got yeah, I'm not sure. Okay. I don't know, I wasn't here, no worries. Let's see, get random, set UID, set GID, set RES UID, write, nothing to see here, move along, just a plain old printf. I mean, if these were relative paths, then we could do path hijacking, but I don't think we can do it in this case. Although it's a good idea. It does try to preload. So LDSO I mean, can we just put LDSO preload in another directory? It seems like it cares that it's in the etc directory. But I'm gonna have to come back to this another time, because we're running out of because I've got a pretty strict deadline these days. All right, so everybody, if you want to do this same challenge, then it's over here. It's called Pathfinder. And I welcome anybody to give this a try yourself. Maybe you can succeed where I failed. But before we go, let's talk about what we're going to be doing next week. So next week is week 20 of 2026. We're getting pretty close to the halfway point. Well, not exactly the halfway point, because, you know, it has to be like week 26. But yeah, we're about a month and a half away. So what are we going to be doing? So we're going to be doing more PicoCTF general demos. We're going to be doing more digital forensics. We're going to be taking a look at the copy fail big local privilege escalation thing that came out this week. But apparently there's a lot more stuff. So that's going to be on Wednesday. On Friday, we're going to be doing some new forensics challenges over at HackerProgs, and we're also going to be doing... Oh, I think we're going to be doing some demonstrations from PicoCTF 2026 for their web apps category of challenges. All right, everybody, I got to get going. My time is very restricted these days. But thank you very much for coming by, and we're going to be back next week. I hope to see you then. But in the meantime, we should look for somebody to raid. InfosecStreams.com has all of your favorite InfoSec and cybersecurity people. And it looks like I'm the only person who's streaming on there right now. Is that true? Let me take a look. So who else is streaming? It looks like we could raid into Rob, RWX Rob. So RWX Rob is a very smart tech person. He loves his Linux. And let's check out what they're doing. I've heard some great things about this guy, the Shy Hat, who's streaming. Well, I mean, he's not streaming. He's not always streaming. That's the unfortunate thing. Okay, so let's start the raid. /raid RWX Rob. All right, everybody. It looks like RWX Rob he's doing some man, are these Briber keys? What are they? He looks like he's doing some Texas toast burgers. What are PicoCTF investigations? PicoCTF investigations is, well, we try to do some challenges from PicoCTF. I mean, this seems to be a pretty fun atmosphere over here. They're doing a little barbecue. Anyways, everybody, when you arrive on Rob's channel, if you could give this message over here, OSFrog, hip hop hack, OSFrog, I would really appreciate it. And ask about those toasted sandwiches. They look really good. It's about dinner time over here for me too. All right, everybody, thank you very much for coming by today. And we'll be back next week. HackerFrogs out in 5, 4, 3, 2, 1. See you next time.